Good evening, children. Welcome to Akshar IIT Foundation. This is Srinivas, your maths faculty. Welcome to today's class. Right. So, while you're observing that, we have discussed some properties, right, about the transformation of quadratic equations. If alpha plus k, comma beta plus k are roots of a quadratic equation, then the required quadratic equation is f of x minus k, right? We have discussed 4 properties in our previous class. Let us go to the next property today. Okay. See here, if the roots of are in the ratio m is to n, the roots are in the ratio m is to n, then we have to prove that m into n b square equals to ac into m plus n. Okay, na? So let us see. Nothing but we know that alpha comma beta are roots of quadratic equation. If alpha comma beta are roots, then f of x equals to 0. Here f of x means what? Required quadratic equation. Nothing but ax square plus bx plus c equals to 0. It's general form. Okay. Now here given that roots are in the ratio, that means ratio another from ratios fractional form. For example, alpha is to beta ratio form. Actually ratio has 3 forms, right? Written form, fractional form and symbolic form. This is symbolic form. When you write alpha is to beta in fractional form, you should write as alpha by beta. The ratio already given, that means alpha by beta equals to m by n, nothing but m is to n. Okay, na? So alpha is to beta ratio of the roots of quadratic equation is given as m is to n. Now I have changed them into fractional form. Change them into fractional form. See, when you do cross multiplication, alpha into n equals to beta into m. Instead of that, I am just interchanging the position of m and beta. I am just interchanging the position of m and beta. So I can write as alpha by m equals to beta by n. Okay, na? For example, if you take alpha is to beta equals to beta is to n means they are equivalent values. They are equivalent values. For example, you can take 1 by 2. What is its equivalent value? We are having more equivalent values like equivalent fractions 2 by 4, 3 by 6. I am just multiplying 1 by 2 with 2. 1 2s are 2, 2 2s are 4. So 1 by 2 and 2 by 4 are equivalent fractions. 1 by 2 and 2 by 4 are equivalent fractions. Now 2 by 4 is nothing but equals to 1 by 2 after cancellation in 2 table. Clear? Now let us check if I am adding these two. 1 plus 2. I am adding the numerators and adding the denominators. Will give the same ratio or not? Let us check. 1 plus 2 how much? 3. 2 plus 4? 6. After cancellation both of them in 2 table, again it will give 1 by 2. That means I am taking 2 equivalent fractions, adding the numerators and adding the denominators. After simplifying, I will get the same equivalent fraction. Okay, let us try with for multiplication also. Okay, so alpha into beta, like alpha by m into beta by n, square root of this. So let us simplify this. Root over, I am taking one of the equivalent fraction is 1 by 2 and second equivalent fraction is 2 by 4. Just cancel it. Numerator 2, denominator 2. What will be remaining here? Root over 1 by 4. Root over 1 means 1 only. Root over 4. 4 is a square number. Square root cancel 1 by 2. But alpha into beta directly not given the equivalent fraction, but its square root is giving. its square root is given. That means when you adding those two equivalent fraction, we will get the same equivalent fraction. When you multiply and we applied square root, then also we got the same equivalent fraction. Same process. That means we can take that when you're adding and when you're multiplying with square root will give you the same answer. Now I am going to take like this form. Alpha plus beta by m plus n equals to alpha into beta by mn with its square root. Why I am taking? To simplify any quadratic equation, first of all, we should aware about sum of roots and product of roots. So that's why I am converting in the form of alpha plus beta, sum of roots and product of roots. Okay? Yeah, what is the general form actually? Ax square plus bx plus c equal to 0. Sum of roots, formula for sum of root minus b by a. Formula for product of roots, very good, c by a. So same I am going to applying here both sides. That implies in the place of alpha plus beta, I am going to write minus b by a into. So before that, let me write in a simple form to understand easily. So I am writing like this. This one I am writing as alpha plus beta into 1 by m plus n. We can write like this also. Numerator and denominator I can separate like this. Okay, na? That implies alpha plus beta value minus b by a into 1 by m plus n. That is equals to root over. Same way, alpha into beta value c by a into 1 by mn. Okay, na? Clear until then? Right. That is equal to root over c by a m n. I'm just erasing this one. Let me check if the place is there or not. Yeah, we'll do meanwhile here. So we got that minus b by a into 1 by m plus n, that equals to square root of c by a m n. So I am squaring on both sides. I am taking squaring on both sides. Okay, na? Now this I can write as minus b by a into m plus n whole square, that equals to another one, root over c by a m n. Squaring on both sides. Square root cancel. Now apply square this side. When you apply the square for minus b, it will be b square, because minus over minus become plus. And apply square for a square, and it is m plus n whole square. Okay, na? That equals to c by a into mn. C by a into mn. Just do the cross multiplication. That implies b square a into m plus n. Sorry, b square a into m into n. A into mn, no, this one. Cross multiplication. Yeah, b square a into mn. Sorry. Yeah, b square a into mn equals to c a square into m plus n whole square. Clear? Now divided by a both sides. What will give? Here denominator a, numerator a cancel, b square mn. B square mn equals to a and a square cancel. That means a square is nothing but a into a. One a will be cancelled. So Ca into m plus n whole square. Yeah, m plus n whole square. So this is we have to prove if the roots are in the ratio m is to n. This is the condition we have to apply. Please note it, children. So just we have taken alpha is to beta is equals to m is to n. I'm just changing it to the fractional form. Then trying to get sum of roots and product of roots. Am I right? Sum of roots alpha plus beta. How we are getting alpha plus beta? Is it possible or not? By taking one example, I am taking the same thing. If you add two equivalent fractions like sum of numerators by sum of denominators, we will get the same equivalent fraction. Same way, square root of two equivalent fractions multiplication, that is also gives the same equivalent fraction. With that concept, I can identify that alpha plus beta by m plus n equals to square root of alpha into beta by m into n. That concept. I am just equating both of them and squaring on both sides. After simplification, the given required condition is got. Okay, na? Please note it. This one just for understanding. No need to write this one. Just focus on it. How this one equal? We know that. How this one equal? By taking an example. Okay? Right. Okay, na? Yeah, I'm just changing this. Right. Squaring on both sides. Apply the square for numerator and denominator each and every term. After that, cross multiplication simplified and divided by both sides. Okay. And this one also. See, if the squares of the roots of f of x is, that means alpha, beta are roots of a quadratic equation. Quadratic equation ax square plus bx plus c equal to 0. Then alpha square, beta square are roots of the quadratic equation f of square root of x equal to 0. This is the condition. Okay, we will discuss one type of model problem also. It is already given in your exercise problems. Okay. Right. Next one. Right. In same way, cubes. That means alpha, beta are roots of ax square plus bx plus c equal to 0. That is nothing but f of x. Then alpha cube plus beta cube. Cube inverse. What is the inverse of cube? Cube root. Alpha comma beta are roots of f of cube root of x. Okay. And here one condition also given. Let us check that condition. So here we need alpha cube, beta cube value. Before that, we used to write if alpha comma beta are roots, then what is the equation? X square minus alpha plus beta into x plus alpha beta equal to 0. Am I right? This is the equation we are going to apply every time. Same way, in the place of alpha beta, if you have alpha cube, beta cube are the roots, then the equation will be x square minus, in the place of alpha, we have alpha cube plus beta cube into x plus alpha into beta. Alpha into beta means, very good, alpha cube into beta cube equal to 0. That means, first of all, we need to find the value of alpha cube, and beta cube value, alpha cube plus beta cube value, and alpha cube into beta cube value. Okay na? But what is alpha plus beta? Minus b by a. We know that alpha into beta is c by a. Am I right? Okay na? We know that alpha plus beta value is minus b by a. Alpha into beta value is c by a. Clear? Now here I am cubing on both sides. I am doing cubing on both sides. That means alpha plus beta whole cube equal to minus b by a whole cube. Okay na? Minus b by a whole cube. So it is looking like one of the algebraic identity. What is the identity? A plus b whole square, right? No. It is a plus b whole cube. What is a plus b whole cube formula? A cube plus b cube plus 3ab into a plus b. I am writing here. What is a plus b whole cube formula? A cube plus b cube plus 3ab into a plus b. 3ab into a plus b. Okay na? Now, same thing you are applying here. Alpha cube plus beta cube. In the place of alpha, think it as a. In the place of beta, think it as b. A cube plus b cube plus 3ab. 3 alpha beta into alpha plus beta. That is equal to minus b by whole cube. Minus b whole cube is minus b cube. Because when the power is odd number, the minus will unchanged. It is remains as it is like that. But if the power or exponent is an even number, then negative numbers will become positive numbers. But when it is cube number or odd numbers, negatives remains same as negatives. Okay na? Right. So minus b cube by a cube. We need to find alpha cube plus beta cube value, right? This one. That means except this remaining all we have to transpose. That's it. Before that I am just substituting the values, then I will transpose. Like alpha cube plus beta cube as it is. This one alpha into beta. Alpha into beta value what? C by a. Yes, I can substitute here C by a. Alpha plus beta minus b by a. That is equals to minus b cube by a cube. Okay na? Now alpha cube plus beta cube value is same. Now multiply. Here plus into minus become minus. Plus into minus is minus. Numerators 3 into bc. 3bc by a into a square. That is equals to minus b cube by a cube. I am writing the continuation part here. What is that? Alpha cube plus beta cube equals to, now this minus 3bc by a square term transpose, that's it becomes plus term. Now here already minus b cube by a cube term is there plus 3bc by a square. And LCM of a cube and a square. What is LCM of both of them? Always highest power. That means a cube only. A cube and a cube one time cancel. 1 into minus b cube is minus b cube plus a square in a cube, a times cancel. A square into a cube. So a into its numerator 3bc. So 3 in a into bc, 3abc. This is we got alpha cube plus beta cube value. Then what about alpha cube into beta cube? I am writing alpha into beta whole cube. Alpha into beta whole cube is nothing but alpha cube into beta cube only. So alpha into beta value c by a. C by a whole cube is c cube by a cube. C by a whole cube is c cube by a cube. Okay na? Just I am taking the sum of roots and cubing on both sides, applying the a plus b whole cube formula, It is in the form of a cube plus b cube plus 3ab into a plus b. A plus b. In the place of product of roots, sum of roots, I substitute values and I transpose that side. Finally, we got the result minus b cube plus 3abc by a cube. And alpha into beta whole cube. This one. C by a whole cube. C cube by a cube. Now, we want this required equation now. Substitute. Yeah, I am here substituting. Yeah, here I am substituting x square minus, we'll complete the problem here. X square minus, what is that? Alpha cube plus beta cube into x. Alpha cube plus beta cube value, this one. Minus b cube plus 3abc by a cube into x. Alpha cube into beta cube. Alpha cube into beta cube is nothing but c cube by a cube. Again same like multiply each and every term with a cube, then this will be a cube into x square minus, here a cube cancel, what is remaining? Minus b cube plus 3abc into x. Here a cube, numerator a cube, denominator a cube cancel, plus c cube equal to 0. This one only we are converting into the required portion. Now multiply with minus symbol. Minus into minus plus b cube, plus into minus minus 3abc into x plus c cube equal to 0. This is the required condition. Okay, nothing but f of cube root of x is equals to 0. Please note it down, children. This one. Okay, now next one. Shall I change the pace? Yeah, let us go to the next page. Yeah, this one. Okay, na? Right. Coming to the exercise 2 problems. We have already completed 4 problems by using the previous properties, right? Transformation of quadratic equations. Right. Let us see this. 5th question. If the roots of the quadratic equation, what is the given quadratic equation here? 5x square plus 13x plus k equal to 0. Yeah, this is the quadratic equation, are reciprocal to each other, then find the value of k. Reciprocal or multiplicative inverse, both are same. Reciprocal, multiplicative inverse, both are same. For example, alpha is the one of the root. You are given that roots are reciprocal. Roots are reciprocal means one of the root is alpha, then the second root is 1 by alpha. Second root is 1 by alpha, right? So these are the roots. I need to find the value of unknown term, that is nothing but k value. Okay. Now I am taking product of roots. Product of roots. First root is alpha, second root is 1 by alpha. What is the product of roots formula? Constant term by x square coefficient. Very good. Constant term by x square coefficient. So in the given equation, what is constant term? K. Constant term by x square coefficient. X square coefficient is 5. Numerator alpha, denominator alpha is cancelled. That implies 1 equals to k by 5. 5 is dividing this side. When you transpose, it is multiplies. 1 into 5 is 5. So our required answer k is equals to 5. Very easy concept. Because both are given as a product of, both are given as reciprocals. So one is alpha, we can take another one is 1 by alpha. Because 1 by alpha, both are reciprocals to each other or multiplicative inverse of each other. Okay, no? Shall I? Yeah, let me go to the next problem. Yeah, 6th one. If the roots of the quadratic equation. Px square minus qx plus r equals to 0. Roots of this quadratic equation are equal in magnitude and opposite in sign. Equal in magnitude, that means value wise both are equal but sign wise different. If you take one of the value is 5, obviously another value will be minus 5. Am I right? So accordingly, roots are same, that means magnitude wise same but sign wise different. So if you take one is alpha, what will be the next one? Very good, minus alpha. If the roots are, let the roots are alpha minus alpha, because values are equal but symbols are changed. In previous problem, if we discussed that, like one is reciprocal to another one, alpha into 1 by alpha, I am using the concept of product of roots to eliminate alpha values, because numerator alpha, denominator alpha cancel. Same way here also, to cancel it, what I should use? Okay, I will only say sum of roots. We have only two options, one is product of roots, second one is sum of roots. So sum of roots formula minus b by, right? First root alpha, second root is minus alpha, that equals to minus b by a. Minus b value is minus q. A value is nothing but x square, coefficient is p. Minus alpha plus alpha cancel, that means 0. 0 equals to minus into minus plus q by p. The denominator you just transpose, it will be multiply. 0 into p is 0, so q value is 0. This is our required condition here. Okay, na? Please note it fast. So today we have discussed, if alpha, beta are roots of f of x equal to 0, then alpha square comma beta square are roots of f of square root of x. Same way alpha cube and beta cube are roots of f of cube root of x. In case alpha power 4 and beta power 4 are the roots, then the quadratic equation is f of 4th root of x. Okay, na? Reverse operations we are using clearly. Alpha plus k, then required quadratic equation f of x minus k plus k, opposite operation minus k, addition opposite. That means when you transpose, it will be negatives. Okay, positive values becomes negatives, negatives becomes positive, multiplies divides, divides means multiplies. Same way. Same like squares, reverse operation or inverse operation of square is square root. Cube inverse operation, cube root. Okay, na? You just remember like that. Inverse operations you can remember. Going to the 7th question. If alpha, beta are roots of x square plus 2x plus 3 equals to 0, this is the given equation. Okay, na? Alpha, beta are roots of this equation. Then the quadratic equation whose roots are alpha square comma beta square. Alpha square, beta square are roots. Then what is the required equation? F of root over f of root x, square root of x equal to 0. This is required equation. Am I right? But what is the given equation? This is f of x. X square plus 2x plus 3 equal to 0. So in the place of x, what I have written? Square root of x. Same condition. In the place of x in the given quadratic equation, plus square root of x. Square root of x whole square. That means x square first term. Second term 2x. That means 2 into root x plus 3 equal to 0. Square root cancel value x. Am I right? 2 into root x, 2 root x plus 3 equal to 0. I am just transposing the remaining terms, remaining two terms except square root term. What is the square root term here? 2 root x. Remaining 2 I am transposing that side. Plus 3 become minus 3 and plus x become minus x. So I can write minus x minus 3. take minus common. Minus of x plus 3. Now squaring on both sides. Squaring on both sides. Square root for 2. Square of 2 is 4. Square root of x whole square is x. Square root cancel. That equals to minus become plus in a square root. I told you when the exponent is even number, the negative values becomes positive. Now it is simply x plus 3 whole square. Expand. Looking like a plus b whole square formula, right? Yeah, tell me the a plus b whole square formula. Yeah, a square plus b square plus 2ab. Same way, x square plus 3 square value 9, 2ab. That equals to x square plus 9 plus 6x. 4x transpose that side. It will be x square plus 9 plus 6x minus 4x equal to 0. There are two x terms, nothing but x square plus 2x plus 9 equal to 0. That is the second option. Okay, now please note it. Okay, children. Yeah. So what are the topics we have discussed today? Alpha, beta, roots of f of x. Then alpha square, beta square are roots of f of square root of x. Same way, alpha, beta are roots of f of x. Then alpha cube, beta cube are roots of f of cube root of x. F of cube root of x. Just remember in your mind, you have to thoroughly revise this. And we have proved those two conditions, even though if alpha, beta are nothing but roots are in the ratio m is to n. There also we have discussed one condition. Okay, by taking alpha by beta equals to m by n, I'm just taking sum of roots, square root of product of roots. I made them equal, both of them. We got one condition. These are very, very important, these three conditions. Just remember it, thoroughly practice. Okay. So until then, exercise 2 we completed 3 problems today. That means 5, 6, 7 problems. Total 7 problems are completed. Okay, na? Right. So that's it for today, children. Yeah, thank you one and all. Have a nice day.